Good day from the Space Shuttle Flight Control Room at the Johnson Space Center in Houston, where at this hour you're watching a replay of video that was shot yesterday of the installation of the huge 32,000-pound, 37.5-foot-long Japanese science laboratory, Kibo, which was lifted by the station's robotic arm out of the payload bay of Discovery and installed on the port side of the Harmony module on the International Space Station. The slow and deliberate process was accomplished by Japanese astronaut Aki Hoshide, along with Karen Nyberg at the robotic workstation at the Destiny Laboratory of the International Space Station. Kibo, now the largest habitable volume on the International Space Station, and today the focus of attention will be the outfitting and activation of some of the critical systems for Kibo in a process that will extend for several days, but today will be one of the more important days as the station crew members get to work.
Go ahead, Discovery.
Hey, good morning, Nick. Mike with you. Aki and I have been on an Easter egg hunt here looking for the saliva kits for a while. The last recommended location was MA16 Delta and Fox, which is a double locker containing totally transfer items, EMU hardware. MA16 Deltas, that's not it. We went through MA9N knowing that's kind of an odd place to throw lots of extra stuff, and it's not in there either.
Copy that, Mike. Stand by.
Again, you're watching a video that is being downlinked by the crew on board Discovery that was captured yesterday of the installation of the Japanese Kibo module. Today, aboard the International Space Station, actually coming up in about 2 hours from now, Aki Hoshide and Karen Nyberg will be responsible for the start of what is known as vestibule outfitting between Harmony and the Kibo module itself. Basically, the vestibule outfitting procedures are divided into 3 parts and will connect all of the jumper cables, the electrical jumper cables, in that passageway between the connecting node and the newest module of the International Space Station. That vestibule will have 2 power lines, 4 jumper cables for the thermal control system. That's 2 for what is known as the low level temperature control system and the moderate temperature level control system. 2 data lines, 2 audio video lines, 1 wireless audio line, 1 high rate data line, 1 Ethernet cable, 2 intra-modular valve jumpers, 1 nitrogen jumper, and 1 water line for condensate water. The first part of the vestibule outfitting that Hoshide and Nyberg will engage in will involve the removal of thermal covers and the installation of jumpers required for the first of 2 power channel activation procedures, Channel B as it is known, which governs the control of the moderate temperature loop, a data cable, and 1 of the power jumpers required to provide electricity and cooling capability for the Kibo module. At the moment, heating is being provided to Kibo and power through the power and data grapple fixture. The station's robotic arm, the Canadarm2, remains affixed to Kibo, even though it is securely bolted onto the port side of Harmony. Its power is being received at the moment through that power and data grapple fixture on the Canadarm2. Once the Channel B activation is complete, Kibo will be on its own internal power, and commanding of that new module will fall into the hands of the Japanese flight control team at the Space Station Integration and Promotion Center in Tsukuba, Japan.
Discovery Houston on 2 for Mike.
Go ahead, Nick.
Mike, some good news for you. Those kits came up on the station side. They are at Lab 1, Overhead 5, Foxtrot 2, where Garrett staged them for you, we believe. If you can't find them there, we would ask that you check with Garrett and see where else they may be.
Okay, copy that. We'll check with Garrett. Thanks.
And Mike, sorry about the Easter egg hunt there.
Getting back to today's activities associated with the activation of the Kibo module. Once all those jumper cables are connected in the vestibule between Harmony and Kibo, work then will begin on the ground and aboard the International Space Station, presided over by Hoshide and Garrett Reisman, to begin the activation of Channel B. The Channel B activation covers the period of time from the activation of DC to DC current units, basically electrical switching units, to the time that the Japanese experiment module, or the Kibo control processor, is activated. All commanding for the Channel B activation must be performed by the crew via its portable laptop computers, or here in Houston, because the commands are sent to the onboard
Houston Discovery for PGSV, or Photo TV.
Go ahead, Discovery.
Yeah, Nick, we have a card in a KFX machine from yesterday, so there's some photographs that you want, if you want to grab them.
Aki, thank you. We copy. We'll look for them.
Aki Hoshide informing spacecraft communicator Nick Patrick here in the shuttle flight control room that digital pictures are available for the team here on the ground to obtain regarding yesterday's activities. Once again, getting back to the activation of Channel B, this is a critical moment in the life of Kibo. The activation, again, will start after jumper cables are installed in the vestibule between Harmony and Kibo. Channel B of the Kibo module is activated first because the moderate temperature loop pump only receives power from the Channel B path of the commanding for power and cooling for the new module, and that moderate temperature loop is needed for the cooling of all of the Kibo systems. Additionally, the Japanese remote manipulator system, which is at the forward end of Kibo, now that it is bolted on to the port side of the Harmony module, the robotic arm for Kibo only receives power via the B channel as well. So during this activation process today for Channel B, some of the Kibo components will be running without its normal cooling until that moderate temperature loop is activated. A final activation sequence will get underway for Channel B after the Kibo control processor, basically the brains of the new module, is activated. At that point, the Tsukuba Control Center, the Space Station Integration and Promotion Center in Tsukuba for the Japanese flight control team, will be primed for performing the rest of the commanding for the Kibo Channel B final activation procedures, and all other activities associated with the interior outfitting and activation of racks that will be installed in the new module. Because of the weight of Kibo, some 16 tons, it could only be launched with 4 racks. 8 racks were launched previously on the STS-123 mission in the Japanese logistics module, that circular storage depot, if you will, which is housed at the moment on top of the Harmony module. It will be unberthed from the Zenith port of Harmony and relocated to the Zenith port of the new Kibo module on Thursday to complete that portion of the continuing buildup of the Japanese segment of the International Space Station. The racks, there are 8 of them, inside the Japanese logistics module will be transferred to Kibo. The first rack to be transferred will be the rack that governs the operation of the Japanese robotic arm, so that Karen Nyberg and Aki Hoshide can begin to unfurl the arm, power it up, test it, test the brakes on the arm, and put it in its final stowed configuration by the time the joint mission to the International Space Station is over with. In all, there are 23 rack bays inside Kibo. 4 of them, again, launched inside the new module on this flight. 8 previously launched on STS-123 in March that will be transferred from the Japanese logistics depot to the new Kibo module. 9 bays will remain empty in the new Japanese Kibo module after this mission is over with. There will be 2 what they call dummy panels installed on STS-124 on this mission inside Kibo to help the crew translate back and forth the length of this huge new laboratory, which is more than 37 feet in length. Those dummy panels will be relocated back to the logistics module after STS-124. Later today, just before 4 o'clock Central Time this afternoon, with the initial activation of critical systems in the Kibo module having been completed, it will be time to activate and open the hatch to the brand new module. The actual initial ingress into Kibo will be accomplished by Aki Hoshide, the Japan Aerospace Exploration Agency astronaut, and Karen Nyberg, who are the leads in the outfitting and activation of Kibo's systems. As has been the case with all the new modules that have been brought up to the International Space Station, they will be wearing protective goggles and masks just to be on the safe side until Kibo has had an opportunity to have the air inside the module cleansed a bit by the ventilation system aboard the International Space Station. So as a precautionary measure, as is the case with all...
That's complete, and we'll look for another take.
As is the case with all new modules, Hoshide and Nyberg will be wearing protective goggles and masks as they open the hatch and enter the new Kibo laboratory for the first time. That's expected just before 4 p.m. Central Time. Other critical activities are planned today. It is a big day on board the International Space Station. Two of the big highlights for the day will be the replacement by Greg Shamatoff, the newest Expedition 17 crew member, and Garrett Reisman of one of the adsorbent beds in the carbon dioxide removal assembly system in the Destiny Laboratory of the International Space. Fossum and Garin in tomorrow's spacewalk will also be preparing a nitrogen tank assembly for its transference from a stowage platform on the International Space Station to replace one that is currently on the S1 truss of the complex, which has expended its supply of nitrogen and will be discarded. They also will retrieve a camera system from the P1 truss, or Port 1 truss of the International Space Station. It has a problem with one of its systems. That camera will be repaired inside on Wednesday and then returned to the outside truss of the International Space Station during the third and final spacewalk of the mission. So a 6.5-hour spacewalk on tap tomorrow for Fossum and Garin, the second of this mission, for a variety of activities, most notably the outfitting of television equipment on the new Kibo module and the preparation for the installation of the Japanese logistics module on top of Kibo, that coming up on Thursday. You're looking at more video being replayed by Discovery's astronauts of yesterday's unberthing of the Kibo module. You're watching a split screen view, if you will, of the Kibo being carefully raised out of the payload bay of Discovery through the use of the station robotic arm that was under the control of Aki Hoshide and Karen Nyberg from the robotics workstation in the Destiny Laboratory. Again, a video replay of television that was captured yesterday that the crew of Discovery is replaying for ground controllers here in Houston.
Go ahead, Discovery.
Yeah, Nick, Mark and I have timeline to do the OBSS sensor checkout in a little over an hour, and we were wondering if we could do it at our next sunrise, which is about 32 minutes from now.
And Discovery can give us a minute or two. We're checking to see whether that will work for us.
Okay, thanks. on space to ground, or on air to ground 2 for transfer.
Discovery, go ahead.
Ready for the transfer update whenever Lisa is.
Discovery Houston on 2 for Mark. Mark, just to be clear, this is not intended as a transfer conference between us. This is just a chance for you to update your book with message 26.
Okay, I got the message. I've looked at it, and if she doesn't have anything else, we'll be good for today for the transfer for the plan.
Sounds good, Mark. Nothing else for you. And Discovery Houston on 2 for the OBSS sensor checkout. Sorry for the delay here. Just to let you know, we're making sure we have facilities and people in place to support.
Okay, copy. It's no big deal, Nick. We were just hoping to do these big arm motions in daylight. That's all we were looking for.
And Discovery Houston on 2 for the sensor checkout. What we can do is give you a go for steps 1 and 2 whenever you're ready.
Okay, that'll be great. We will do 1 and 2 at about 23 minutes.
Houston copies. We'll be watching. Discovery Houston on 2 for Jedi messages.
Yeah, Nick.
Message 32 is on board. It's the ACBM Hatch MLI crew brief. We'd like for you to verify for us, please, that that has printed. Message 33 is on board electronically only for you. It's contingency channel A timeline. And in addition, we've taken the photos off the KFX card. You have a go to change cards.
Okay, copy all.
This is Mission Control Houston, continuing to watch television that was downlinked yesterday and being replayed by the crew on board Discovery of the delicate process that occurred throughout the course of several hours yesterday to unearth and install the Japanese Kibo science laboratory onto the port side of the Harmony module.
We have it on board. 32 and 33 is there as well. 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 32 and 33 is there as well.
While we watch
Ken, thanks for the
this
info.
video being replayed by the crew of Discovery, down the hall from the shuttle flight control room in the International Space Station flight control room.
I think earlier you guys said that they should be sitting in the printer, and they weren't. We just print them out.
Copy that, Ken. Thanks.
Space Station Flight Director Bob Dempsey has received a briefing from NASA flight controllers at the Russian Mission Control Center in Korolyov outside Moscow, belonging to what is known as the Houston Support Group. They have been briefed themselves on the procedures that will be undertaken about an hour or so from now by flight engineer Oleg Kononenko in his replacement of a gas-water separator, a gas-liquid separator pump for the Russian toilet back in the Russian segment of the International Space Station. The current gas-liquid separator pump has had problems separating the urine portion of waste material, placing that liquid waste on the normal path into a urine container in the plumbing system of the Russian segment of the International Space Station. As a result, a couple of pump replacements over the past 10 days have not produced success. This does not affect solid waste collection, only liquid waste collection. And as a result, a new gas-liquid separator pump that was ground tested at RSC Energia, which manufactures the hardware for the Russian segment of the International Space Station. That new pump was flown aboard Discovery, was transferred over to the Russian segment of the station shortly after docking on Monday, and today will be installed in about a 2-hour procedure that Kononenko is about to begin about an hour from now. Just to recap how the onboard potty works on the International Space Station, the service module toilet is operated from a urine collection system panel and a toilet control panel back in the Zvezda service module. The urine collection assembly works with the commode portion of the toilet system to form the bulk of the waste collection capability. It's based on transporting urine via airflow to this gas liquid separator unit after a filter has removed brine from the liquid. The gas is then filtered by the collector through the separator to remove any carryover moisture, and then is returned to the cabin. Basically, the air is recycled. The liquid is mixed with amounts of pre-treated material from a container and water from a flush water container. The solution is mixed after the air is removed. The amount of pre-treat material is determined by a pre-treat and water dispenser in the plumbing of the service module toilet. The liquid mixture then stored in the urine collection assembly. When that assembly is full, it is changed out by the crew and stored in the Progress resupply vehicle so it can burn up during atmospheric re-entry. The current Progress that is docked to the International Space Station is the Progress 29 cargo ship that arrived several weeks ago, carrying 2.5 tons of food, fuel, and supplies for the crew on board the station. So Oleg Kononenko, wearing goggles and a mask and gloves, will be busy back at the aft portion of the Zvezda service module in the ship's potty today as he changes out this gas liquid separator pump. It is believed by Russian specialists that it is the culprit, and that the change out of this newly ground tested pump that was flown from Moscow to the Kennedy Space Center and loaded aboard Discovery will be the solution to the problem that has caused only inconvenience for the crew on board the International Space Station, essentially forcing them to use backup urine collection methods. That has only been a time-consuming issue for them, not a sanitary issue. While the toilet pump is being replaced, Expedition 17 Commander Sergei Volkov will be inspecting windows in the Russian segment of the International Space Station, part of the normal maintenance work that is ongoing aboard the complex from time to time. That happening simultaneously with work that will be ongoing in the Destiny laboratory of the International Space Station by the new Expedition 17 crew member Greg Shamatov and the man he replaced, Garrett Reisman, who will be working to replace one of the two adsorbent beds in the carbon dioxide removal assembly in Destiny. That is the carbon dioxide removal system that works in tandem with the Vozduk carbon dioxide removal system in the Russian segment of the International Space Station. So both the shuttle and station crews working their way through the review of morning messages, getting a bite to eat, reviewing their mail, and getting set for a variety of activity today. Again, the other major activity that is on tap that will be getting underway at about 11:15 this morning Central Time will be the start of the activation of the newly installed Japanese Kibo science module. This work will begin with the outfitting of the vestibule that connects the Harmony module with the newly installed Kibo. The vestibule outfitting procedures divided into three parts, starting out with the connection of power jumper cables in that small passageway between Harmony and Kibo. The vestibule has two power lines, four thermal control system jumpers, two for the low temperature loop as it is known, two for the moderate temperature loop, two data lines, two audio-video lines, one wireless audio line, one high-rate data line, one Ethernet cable, two intra-modular valve jumpers, one nitrogen jumper, and one condensate water line. The first part of this vestibule outfitting, which will begin in advance of the actual power channel activation for Kibo, will start in about an hour. That will involve Karen Nyberg and Aki Hoshide removing thermal covers and installing jumpers required for the Channel B activation. That procedure also installs a low-pressure nitrogen jumper, even though it's not required for this first power channel activation activity later today. The second part of the vestibule outfitting will install all the remaining jumpers except a Channel A power jumper due to tight access between several clamps and jumpers in that narrow passageway. The crew requested to install some of these jumpers after the intra-modular valves are installed to provide the proper ventilation between Kibo and the rest of the International Space Station. Once all the jumper cables are installed in the initial phase of the vestibule activation procedure, then the crew will be able to get down to work in the activation of Channel B. This is a critical activity this afternoon for Kibo. It is currently receiving power and the correct thermal conditioning for its shell heaters for the hull of the module.
Houston Discovery, air to ground 2.
Go ahead, Discovery.
Yeah, feel free to come on board on the flight deck whenever you want.
Wilco, thank you, Mark. We have KU. We'll come on board now.